I would like to give my introduction as already sir has given. I'm Dr. Piyush Pant and I'm the professor in BPIT Delhi presently. And we all are living in Delhi, and mostly people of all across the country have joined here. But in Delhi, I would like to say that the weather is very unpleasant. Lot of dust particles and pollution is in the atmosphere, and it is the issue that we have to think today and for the future also. And by and large, this I am saying because our target for tomorrow technology will be based on all these factors. So as far as this discussion is concerned, my aim is to discuss here about the small capacity generation by harnessing the sources, actually those which are in the form of small rivers. They are the form of canals. They are available everywhere and have the electricity which is frequently available to us. And we say them as a pico hydro systems, micro hydro systems, like that. And we have to generate quality electricity from them. The electricity can be utilized for the isolated locations and also for grid coupling. I think that few of you are quite not familiar with this. Some of the people, maybe the electrical people, engineering people, electronics people, who are quite familiar with these all terms. But if we say that what is electricity and what is quality electricity, so this is actually becoming a very important term in today's life. Actually, electricity is selling as a product for today. If we want to generate electricity, it should have the proper quality, like the bottle of Pepsi, like the wafer of Lay's. If the quality is not proper in that product, so the consumer will not accept it. Similarly, in the deregulated market, what is happening that the electricity we want to produce should have proper quality. I would like to tell you in the next few slides that what actually the power quality parameters are, but just you must understand that if you are not, if the generator side is not supposed to generate, maintain such parameters, then nobody is going to accept that quality. And now we have the two different sectors. One sectors are the places for the overall growth of any country or any location. It is very important that each people, everyone should have accessibility to electricity. Now, it is not every time possible to erect electricity grid. Many of us are familiar that we have the villages where electricity grid is not present, even though we have to arrange some form of lightning arrangement for them. So that location are called the isolated locations, where no term of electricity grid, no electricity poles and lights and anything is there. But how their people will be fed? So they have similarly the different type of the arrangement. And second thing is that it is called the grid coupling, right? And grid coupling is actually the grid we have available. Suppose for an instant, we say Power Grid Corporation of India. It is one of the important body of government of India, which is handling how the electricity will be transmitted from north zone to south zone or any part of our country, or we have to transfer that electricity to other countries also. So that is one of the things. So grid is very rigid thing. Grid has enormous amount of the power which can be delivered to the consumers, to the industries. But isolated consumer are different one. You can see that some people is using the solar panel and he is getting sufficient electricity to light his or her home or some any other application. So this is the difference actually. And as far as the technology is concerned, so there is a in words, it is very simple to say isolated applications, grid coupled operations, and quality electricity. But as far as the development of technology is concerned, so it has taken already many years to come to this level and to utilize some new source and to generate such quality with that. So in this session of webinar, I would like to give you discuss some of the introductory part of it. That why I am advocating this micro hydro. Actually, micro hydro is likely the new term for many people for us. And then we will discuss that how the in isolated location how we can generate the quality electricity, and also we will discuss some point that how the grid coupling can be done. See, these are the point. Actually, they are under research also. They are implemented also. If we talk about the engineering and technology peoples, like we are the students here, some people are faculty members, some of our industry people, some of our users there. So they have their own level of working. A student can think about that, what should be the scope that we can develop new sites where the electricity can be generated. Technology person can have to develop that in the form of the product type. Then third category of the users, he will say, yes, give me such electricity, then I will use it. Or I have the instrument which is not able to work on this voltage you are providing us, so I am not able to take this voltage. Or he will say, yes, your power is very good, you are the very good user. So in country like US and Europe, now they have actually driven towards the competitive market. We will have 2 3 suppliers in your home, and you have the ability to check, like in your mobile phone you do that, you have different type of the sim supplier company, and they will give you the sim, and if you are not getting the good service, you change that sim. Similarly in electricity also, this will be the future, that we will have different 3 or 4 companies will be there, and they will be providing you electricity. If somebody is not able to give you 24-hour electricity, then you will say, no, I am not interested in your supply, because I am not getting the supply in the proper manner. If you are not getting 24-hour electricity supply, so why you have to pay money for that? You can claim it in that time. Different type of the things are actually available in the globe, and the future is that anytime after 5 years, after 10 years or 20 years, we have to face them in our country also. So obviously for this these things, the motivations actually goes to the fact that presently that I was starting at the starting of my in this seminar, I was saying that the pollution in Delhi is too high. The reasons are many. We cannot cite any one reason, but as far as this uh, slide is depicting you, and in YouTube, I think the slide has not been changed, but uh, this slide is actually depicting the sense that we have to generate electricity by more dependency of renewable energy resources. This is actually the future of electricity. There are many countries in the world which have turned themselves toward renewable energy. And in the simple second part of the slide, where you can see that how the world and India are utilizing or generating the electricity they have. See, the data percentage can be changed. This is a data for, I think I have, when I have collected this, new installations are there. But this is a tentative, actually, the distribution, that most of the power which is in the globe as well as in India, you can see that it is coming for fossil fuels. Second option is the hydroelectricity. It is one of the important generating systems which are contributing for electricity generation. See, and the third one are the nuclears. And anybody of you can tell that what is the problem with fossil fuel. The very first thing is that they are depreciating day by day. NTPC, they are not having sufficient amount of coal to burn it and generate the electricity, and that is actually the future also. How, from where we are getting the coal? Simple thing. Hydroelectricity, these type of the projects are actually very time consuming. They require a lot of economic factors also. You can say that the hydroelectricity plants have the very long gestation period. It takes 20 years to complete the project. Maintenance is very issue. So again, the things is not quite practical. We can see only in India also, we have not developed so much hydroelectricity plant in after our independence, which were developed are not operating at full load. There are technical problems, there are economical problems, there are political problems. You have to rehabilitate the things, that are the issues. Third one is the nuclear. What are the issues with nuclear? Nuclear. Japan was one of the country which was depending upon the nuclear, but we can always get the data that nuclear, if it is harming the mankind, so what is the use for generating that type of the power? So people are not going to motivate by the nuclear power also. So what left? What left in both of the graph, globally as well as in India? Only the renewable. And you can see this type of the figure what I'm showing to you will be it will be grabbing more area on this graph after, and years by years renewables will be coming into picture. And I would like to cite the example of country like Denmark. Last 2 years they were generating 45% of their total consumption with renewable energy, because the reason is quite simple. For tomorrow, if our aim should not be only to generate electricity and to develop the equipment which give us comfort. Okay, we have to run our AC also, we have to run our heaters also, we have to run our industries also, but not at the cost of this pollution and cutting our trees and disturbing our environment, because for future our children have to live there, they have to survive on the same country. So this is actually the requirement of the future, that we have to be more give emphasis on renewable energy resources. So what are renewable energy resources? It is actually quite burning topic from last 10 years. Lot of investigation research is also going on. If you see the good publications and anywhere publications, those who are doing research, so most of the peoples are focusing there towards the renewables energy sources. But if we talk about the renewable energy, so what renewable energy? Solar, we can say solar, it is a renewable energy form. Wind energy generation, it is a form of, again, the renewable energy source which can generate electricity for us. Good work is going on, good research is going on, quite plants are also there. But I have tried to give you in this slide something about that new idea, that how this micro hydro type of systems, pico hydro systems, which we can exploit the energy by utilizing our rivers, our small canals, which are naturally available to us, can have the very good potential to develop electricity. If you see in these four graphs, so if somebody want to generate electricity in some rural area, so first option he has simply is the diesel generator. Diesel generator, what is a very bad where diesel generator is not getting good marks? Because its environmental effects are very bad. It is polluting the atmosphere, you're burning the diesel or the petrol, so that the things are not okay. Second is obviously the fixed and running cost. We can see that in some places the petrol diesel cost is rising day by day. We are not having sufficient petrol for vehicles, so how for our diesel? So it is not actually the solution, permanent solution to generate electricity. Second, we can go for solar PV, right? Solar PV, again, in the second right corner you can see that what is in the solar, the energy storage requirement. The solar is lagging its marks in energy storage requirement. That means the solar systems which are existing today have not capability to generate electricity in night times. Somebody of you might not have about these terms. I would like to give you the recent research that after 20 years, the solar, after even 10 years, 5 years, if the research will be sufficient, then we will be having the electricity from solar in the night time also, because radiations are available. But in today's scenario, whatever the solar systems we are using are not so much capable to give us electricity in night area. So what we have to do in nights, actually we require the lightning, we have to study in night times, we have to run our television sets on the night time. Most of the work at till 11, we need the electricity from 6 to 11. So what is the solution? Simple thing, we use the battery, no other thing. Battery is very hazardous. If you go through, one of the important thing of technology is the hazardous waste management. I'm not talking too much on this thing, but it is one of the burning topic of today technology and political side, that hazardous wastage, all the electronics wastage, all the computer chips and mobile phone, it is very difficult to handle all these things. They have the heavy materials, and how to dump them, how to extract actually the material which is available on them to form the real product. Because even if you can imagine yourself, anybody of us changes in his mobile phone in 2 years or 3 years, so the old one becomes the hazardous waste. Okay. Similarly, the battery, what is in the solar PV is a hazardous waste. They have the assets in itself. You put it in the ground, it will be wastage. So it is not actually the good solution. Second, solar PV. Anywhere you install, you have to clean its surface properly. You have to clean the surface solar. Otherwise, its efficiency will be removed, not be as good as it was designed actually. So it is cumbersome work. And even for the large applications where any industry is coming into focus and they are maintaining it, their manpower, deploying dedicated people for it, it is okay. And even I'm saying that it is one of the good promising source of renewable. The third one, you can say the wind generation. Again, the issue with the wind generation is energy storage requirement, because what is in the wind? Wind, sometime wind is available, sometime wind is not available. You have to control the pitch angle. The wind turbines are there. You have to synchronize them. Otherwise, your power will be fluctuating. We can say that power electronics technology is there which can regulate all these things, even though some person for his personal use is not interested to install wind generation for his requirements, you know. So from that point of view, I would like to advocate pico hydro systems. What our basically the topic is, pico hydro means that I have given you the example that a small river is there in your locality. You can just put the generating system, float the generating system there, and you generate the electricity for your house, for your two house, for your neighbors also. You can sell that electricity also. One thing, it is reliable actually. Reliable means a river is there, it is flowing in the day also, it is flowing in the night also. You can get the, you cannot say that tomorrow the weather is not good and you will not get the electricity. Such type of the forecasting is not required there actually. It is continuously available. Reservoir requirements are not there. Reservoir requirement is for big hydro systems where our big generation is there. But for small hydro, naturally what the river is, we can utilize that thing. Battery storage requirement can again be eliminated, and we can go for the cost effective generation, because if all the things are involved there, so the things will naturally cost effective. We can generate our electricity at the very minimal cost. Only the installation cost will be there, and few amount we will be in the maintenance. Otherwise, no such thing will be there, and it is very robust. Actually, I will cite something. I will give you the example that how we can make it robust. You just throw it in the river and you can generate the electricity. Okay. So uh, as far as if I'm saying that micro hydro projects are there, so one important thing that is emerging is that if we take the example of only our country, that is India, so there are a lot of promising scopes the micro hydro projects have. Like, you can see the list of different states. See the potential. Andhra Pradesh has potential of 497 such micro hydro which are identified. They are identified by Government of India and different agencies. Arunachal Pradesh 550. You can see the list. Kerala 245, West Bengal 203, and they have the very good potential to generate the electricity. Right? If you cumulate them, so in India we can develop 5,718 till date. What are the potential that government has cited? That after the good civil engineers go there and they propagate the site, then they say that yes, this is a place which is okay, and we can develop some systems here which can generate electricity. They are actually Ministry of DST is also working. They have the separate department for micro hydro also, and they identify after many consultations such type of the potentials. But the thing is that how many projects are installed and how many projects are under implementation. Project installed, they are quite less in numbers. You can say that if we can just take the example of Andhra Pradesh, so almost 500 projects have the capacity to install, but we are not even lying on the range of 60, 63. That means even 10% are not installed, and installation is going on very less, right? So when such thing is happening, so why this happens actually? Do you know the reason that if something is there and it is not happening, if something is possible but it is not happening, so what is there? There are some bottlenecks, some issues. Something is there which is obstructing the development. In every state, you can see that lot of potential is there, but project installed and implementation are less. So I would like to give you that the figure that how this type of the system will look. See, if you can see in the places where micro hydro projects are installed, so they are very small in space. Just small motors are there, and I am talking about the system which are 10 kilowatts, 20 kilowatts, 50 kilowatts, like that. In our home, I would like to say that the 5 kilowatt electricity is quite sufficient. In Delhi apartment, they are providing 5 kilowatt electricity for all. We can run two ACs and some more appliances in our home with 5 kilowatt for Delhi itself. But if the area is rural, 1.5 kilowatt, 2 kilowatt is sufficient. So for a single unit can uh, give sufficient amount of the power. This similarly, they are the different figures where the things are installed, and they are quite not big installations. Not they will look like in particular industry where you have to install all these things. But our challenges which are coming in the micro hydro, uh, that I was citing you the thing that in each of the state the things are not quite motivating. The reason is that we have to check that in the places where the micro hydro system are installed, so what were the issues. So I have taken some examples that Thalupalli micro hydro power project, it was 20 kilowatt power project, and it is operating in Tamil Nadu, right? And the issues they were facing is that it is a site specific technology. You have to put the roads also there, you have to put the machine arrangements there. Sometimes the uh, some disturbance occurs, so there should be the accessibility of the person who can reach there, and they are confined to specific type of the loads. I will tell you that what are the issues concerned, but a specific load means only you can run your electricity bulb. If CFL there, it will not run, it will not operate. But if the incandescence bulb is there, it can run. So if the technology is trending from incandescence bulb towards the LED bulb, so your generating site should also cater its requirement. But right now it is the issue with them. Second, Nepal has 150 stations, but they have not scope for their energy expansion, right? We can see in Rwandan hospital, they are supplying electricity to their national grid. They are looking to generate, but the grid coupling issues are there. Whenever any fault occurring in the grid, it is affecting your small generator. Your generator is very small, 5 kilowatt. Grid is very huge. And if you are connecting with it with a grid directly, so if any problem occurring in the grid, it is affecting also your small generator, which is of 5 kilowatts. So again, you have to maintain it. You have to put somewhat your money to maintain that. It becomes the issue again. That grid coupling is there, and they are not immune to fault. Actually, fault immunity is the very important term nowadays. Something happening, your generator should uh, remove itself from that issue. It should sense that thing, and it should remove that thing with there. Also, I would like to cite that many in across globe, many private-led companies and government-led companies in Tanzania, Kenya, Rwanda, they are all African countries. Many international giants are also went there, and they have installed these systems. But they all are basically working on the fixed excitation control, because in the electrical technology, we have to give the excitation to the generator, and we have to run the turbine, and then we can generate the electricity. But if that excitation is fixed, so your voltage and fluctuation, if it is happening with the load, they all are actually not controlled by the user, and that is actually causing the transients, or they are actually not good. So these are some major issue, and last seasonal variations are there. So these are actually the things are facing. So accordingly, my aim is to address these things, that how, what are the few things that I have also understand in my work, in different research work in different industries, that what are the issues, and that I would like to share with you. And obviously, according to your working, you can work on that side, you can find interest on them. So the very first thing is that whenever we are generating the electricity, the very first fundamental that was proposed is that in magnetic field, if you run any prime mover, it will generate the electricity. That is basically the function of a generator. And for micro hydro, we can prefer synchronous generator. We can prefer DFIG. It is a doubly fed induction generator. This is the third one is PMG, permanent magnet generator, switch reluctance generator, or we can use the induction generator. I would like to make you clear that these all are generator also have particular research scope in itself. Synchronous generator, it has to be run at fixed speed. If the speed of is not fixed, there are many concerned issues in the generator. Its frequency will disturb actually. DFIG is a big generator. It is doubly excited machine. You have to give DC also. Permanent magnet generator, you have to provide the excitation, and some complex technology is available in PMG and SRG also. And induction generator, actually self-excited in induction generator, they are basically the main generator which are implemented in existing systems, and there is no issue with the induction generator if we utilize this generator for electricity generation. So this is one of the good generator which is existing and requires less complexities for its operation, because overall the purpose of the technology is you must provide very simple solution for your users. It actually the requirement of any people who are working in computer side, those want that the app should be very easy for the consumer. We use Uber app, so it just asks you where you have to go, where you are going, where you have to go. That's all. Nothing nonsense. Similarly, our generator should be very easy, and from that point of view, I would like to advocate induction generator for micro pico hydro project. So what is induction generator actually? Induction generator is simply the induction motor, you can say. It is a three-phase induction motor, or you can use single phase induction motor also, but my emphasis is to work on three phase because it is very having some good parameter in itself. Balancing and many other issues are there, and sometimes our load is also three phase, so they can cater that type of the load also.
All the participants, please wait 5 more minutes. Maybe resource person is disconnected.
Sorry, there was an interruption. I don't know. It was a technical fault, so you have to bear. So anyway, I was discussing. We are looking over the facts accessibility. Accessibility means today I go to the market. I will ask the people that give me an induction motor. He will immediately in 5 minutes he will give me induction motor. For other motor we have to give orders, or even they are not as easily available, so that is the issue. Second is the cost effectiveness. It is one of the motor which is available in least cost actually. uh, it is also the motor which is mostly used in the industries, induction motor. Third one is the robustness. It is the robust motor with the different say effects, and with the different atmospheric changes, different chemicals. These type of the motors are not affected very badly, and they go on working. They have the brushless rotor, and the structure is quite fault immune. Technically, if some fault occurs and balancing type of the issues come in the motor, or some transient currents are there, so they can easily uh, absorb it, and they are quite termed as the fault immune structure they have. So this is one of the things that about the motor, that induction motor I am saying to be a best suitable motor till date. Even the research is going on, and in future the technology will be different than today, and we can be able to use some other motor also. But for today's technology, I actually advocate induction motor. And second, now the important term is what is power quality. Now, please, if I say that generation of the electricity can be done only by revolving a rotor in a magnetic field, you will generate the electricity. Or you can see that some voltage will be developed there, some frequency will be there, some oscillation. Is that electricity usable for the load? The answer will be no. Because anytime when you see the electric bulb, there is the voltage particularly written 220 volt, 50 hertz. If you are not giving it twice, the bulb will be 50 volt. By over voltage it will get damaged. If you will give it 200 180 volt or 170 volt, so there can be the different type of the issue we can see. So for the consumer point of view, he need quality electricity. That also something I have discussed in the first point in the priorly in this seminar. So what are the power quality parameters? The very first Hello, am I audible?
Yes, sir. Sir, it's audible, sir.
Am I audible, sir?
Yes, sir. Please continue, sir.
Okay, sorry, there was some regular interruptions, and uh, so in case of power quality, we have to check what is our frequency we are generating. It is very important actually. In India, our frequency is 50 hertz, and for grid point of view, different grid regulators, they are maintaining this frequency by asking the generator side that what operation or what technology you have to make, or at what speed you have to run your generators, or to put the load, so that it should be maintained. But as far as if we are working in some isolated manner where nobody is there to regulate us, so how we have to control the frequency? It is the important thing. Our voltage which is generating by our generator should be fixed. It should be constant. There should not be any disturbances on the magnitude. There should be no flickers. Actually, flickers are that they are the disturbances in the voltages. There are some voltage sometimes ups, sometimes it downs, and type of the flickering we get. There are the voltage dips, swells, voltage interruptions are there, and harmonics. They are technically come from the operation of power electronic devices. So they should also be controlled. So at least for minimum these parameter regulation is our duty. Mic is not coming, sir. What? Audio?
Yes, sir, it's audible, sir.
Problem in audio, sir?
Sir, no problem, sir, it's audible.
Sir, may I know some issue? What is the problem getting? Hello?
Sir, it's audible, sir.
Okay, sir. Everything okay, sir? Okay. So, hello?
Yes, sir.
Hello?
Yes, sir.
Yeah, Kiran sir, I do proceed.
Yes, sir. Proceed, sir.
Okay. So there are few disturbing power quality issues in micro hydro generation systems. Uh, they are just been on your board. We can have the very big disturbances with the turbine side. Whenever anything, any issue or any debris which come to the turbine side, it calls the disturbances, and that disturbance will cause the disturbed voltage and frequency. We can have the large voltage, low voltage ride through capability if not okay for a system, then we can have the disturbance. The third issue that can be there is about the starting operation of induction motor. Induction motor during starting draws a lot of current actually, and if that current is transferred towards the generator side, so it can cause its overloading also, and transient overloading actually the issue. And we can have the intermittent constant power loads. These are actually different type of the loads, like in the SMPS power type of the supply, charging of e-vehicles. Ultimately, we have to use that type of the load also. So we have to cater the things such that the constant power load should not disturb the generator. So as far as now our discussion second point is concerned, so it is the
isolated operation. So what if we are operating the generator with micro hydro system coupled? So in isolated case, what should be our strategy? What are the methods? Few methods I'm proposing you. Because modern electrical loads like SMPS, e-vehicles, constant power loads, they are actually the modern electrical power loads, and they are very much applicable to the rural locations. For example, I can say that e-vehicles are required to be charged in remote locations also. Where your road is there, you have to do some arrangement to charge electric vehicles. We have to give the computer to the people who are in the rural locality also. We have to develop that children also. So from that point of view, the challenge is, what are the challenges we have to face to develop the control algorithm for voltage and frequency regulations. Now, control algorithms are completely developed with the help of communication engineering as well as computer part and power electronics switching of the systems. These systems are very important and they have a very important role if we want to develop quality electricity, because better the control we will do, better our we can say the quality of the power will be there. Establish generator to feed constant power load without observing the voltage collapse. The CFL type of the load should also be catered. We can start induction motor in effective manner, and we have to develop the solution for voltage sag recovery, low voltage right through, and uh, fault immunity type of the systems. So these are some of my suggestions that was basically the aim of this seminar is to develop some solution, to propose some solutions that how we can generate the quality electricity. Quality electricity, I have abbreviated many terms. It should have constant frequency, constant voltage, constant flickers. So it actually required that what type of the load we are using. Suppose I can take the example of simple electric heater. I have to do electric heating. From that point of view, the big harmonics and things are not the concern for me. But if I am running some electronic medical devices, there the harmonics and frequency will play a vital role. So this is the point which are required to be concerned with the engineers, that what issue should we take so that we can get the maximum utilization of our things, and we can get better quality power. So this is the technique that I am proposing to match the real power of micro hydro system with grid connectivity provisions. So the aim actually is that whatever the power the micro hydro is capable to generate, it should be transferred toward our load anyway, and the system should have also the provision of grid connectivity. Suppose in future that particular isolated location will having the electricity grid proposed by the government, so our system should be connected with this, and at the starting level we can give the provision for that. And this type of the very good example I have thought about it, we can propose the effluent treatment plant on the rivers. Effluent treatment plant, whatever the people throw in holy rivers and many things, our restaurants and our many places which put the garbage on the rivers, they should also be treated as a effluent, and our motor will be run, our generator will run, they will treat it by that centrifugal action, and finally the water will be treated. So it will be the good example if at micro level such type of the system will be operatable, and we will get the treatment of the rivers like that. So in that case, we can see that the flow rate of effluent is fixed and it is offering the constant head. Minimum hardware approach for cost-effective solution to induction generator-based generation at near constant frequency by matching of connected load with the generated power. I am matching the load only for the purpose that in case anything our load is not attached, so generator should not having surplus power to deliver, because if in case the surplus power will become, the generator will be come to the over speed and its voltage will also increase. So we have to take care of the fact that the power should be maintained. Whatever energy balance, actually, this is the theory behind it, that whatever the power we are generating should be in the losses and go through the load. That we have to maintain in every place, either it is the economic place. This is actually the configuration that I am proposing, and here we can see that this is a micro hydro turbine, that what it is there. It is operated with the induction generator, and we have applied the simple capacitor bank. No complex device is there. A simple capacitor bank is exciting this generator, and obviously when the generator is exciting, we are getting the voltage across the terminals. We are setting the value of the capacitor so that we are getting 440 volt line to line, and we are getting the rated current of the motor at its terminals by putting the sufficient amount of the load. Now, what is that load? The load is reduced by two parts. The first is the VFD. It is the variable frequency drive, which is actually doing the effluent treatment work. And sometimes the load of this drive, if becomes lesser, then the load controller will come into action. So the total load, whatever the voltage control drive and this load controller and VFD are in total giving, will be the load of the induction generator. Otherwise, its frequency will increase and its voltage may also